report a little bit about this. Okay, so like I said, I don't want you to write this down, all right? And you're going to put that away right now. Yeah, put that away. Time has passed for that. So we're going to talk about population sampling. So we've been talking about ecology. We've been talking about organisms. We've been talking about organisms moving into an area and reproducing and causing population growth and all that type of stuff. So now we want to talk about the practical part of actually determining a population of an organism, okay? And so in my first note, and again, you don't have to necessarily write this down, ecologists need to count the number of a particular species. If you're wanting to write it and you want to write quickly, you can. That's up to you. But the video is going to be there. And I'm going to go fairly quickly because I want to get to the point to where we're going outside, okay? So if you want to write quickly, you can. If you want to get it later, you can. If you want to just watch the video, go back, you can. So in order to study ecology, we need to know how many of each species there is in a particular area. So what are we going to do? We're going to do this by doing something called random sampling, all right? In many populations, there's no way to be able to determine the exact number of individuals in that population. It's either too big, so you can't count all of the things, or the area's so big you can't go around and count the whole thing. So how do we get an estimation of a population if you can't count them all? All right? So what we do is we do something called a random sample. We pick a little spot, we count. We pick another little random spot, we count. We pick another random spot, we count. And then we take the average and we try to figure out what the whole thing will be. Okay? That's what random sampling is. Counting each member of a population is not possible. Several smaller areas chosen at random can be sampled and used to estimate the entire population in a community. So we will do this sampling, all right? And that means we can't count them all, but we can count little bits. So how do we do it for plants? We can use something called a quadrat sample. You need to listen this way. It's super important, all right? There is an example on here that I'm going to do. That is how you do the lab. That's on my little culminating activity. And I'll tell you right now, there's a question just like it on the test. So you need to pay attention so you know how to do this. So we're going to use the football field as our area that we want to study. We're actually only going to use half of the football field because the phys ed people want to use the other half, crazy phys ed people. So we're actually using the half out that way. I don't even know what the direction is, but it's that far half, okay? And we're going to want to try to determine the number of dandelions on that half of the football field, okay? There's no way to run around and count them all. I suppose we could, but it would take a lot of people and a lot of time. So we're going to pick random areas and count them in that little area. So we need to define what the area is going to be. The technical term we use to describe the area that we choose is a quadrat, all right? Just a goofy word. Quad means four, so it's a four-sided kind of square. And usually it's 1 meter by 1 meter. When you go out to do your quadrat, we're not bringing meter sticks because we practiced. Remember at the beginning of the year, we practiced our 1 meter paces? You're going to use your 1 meter pace to estimate 1 meter by 1 meter, which is going to limit our significant digits. We're really going to know it to really just kind of 1 significant digits, maybe 2 if we've got a good pace. We could say we're pretty close to 1 meter. Okay, so then what do? We put the boundaries of our quadrat. What you're going to do is you're going to use pencils or pens. You and your partner are going to bring 4. You're each going to get a piece of string that is slightly longer than 4 meters. Could you take the music out, Jess, please? And once you've got your quadrat, you can wrap the string around the first pencil, go around the other pencils, and designate your quadrat, 1 meter by 1 meter, as determined by your paces, okay? Once you have that, you can count the dandelions within them. okay? I'm going to tell you how you're going to find your quadrat in a moment, because we need it to be random. And we will use a random number generator to locate your position on the football field. I'll talk about that later. Once you've got your quadrat, you're going to count the organisms within the quadrat. Just count them. And you'll write that down in your lab book. You'll write down where the quadrat was, and you'll write down how many dandelions were in it. Now, my son did this during the summer. I told you that he was an ecologist. He worked at the finery. He said there's something that you've got to take into account, though, that I thought was interesting. He said you need to have a plan for the edge effect. What if you get a dandelion that's right on the string? Do you count it or do you not count it? So you need to come up with a plan for the edge effect. You can't count them all on the edge because then you'll have too many. So what my son said, what a good one to do is, if they're on the top, you count it, and if they're on the right, you count it, but if it's on the bottom and on the left, you don't count it. Right? So you're only counting one side, but not counting the other side. But you can't count them all because then you'll have a number that's too big. You see what I mean? You'll have too many in it. So try to have a plan for your edge effects. If you do the left and right thing, you always got to be facing the same direction, though. If you change your direction, then your left and right is going to break down. So you always got to be facing the same direction. So consider the edge effect. You might not have any on the edge, and then it might not be a problem. So then, you count your quadrat and write it down. And then you do another one to see what its population is. It may be lower, it may be higher. And then you do another one. You're going to do 3 quadrats, okay? We're going to share all of our information on a Google Sheet because each of you will do 3, or each pair will do 3 quadrats, and then we can get more data by sharing each other's data. So it's like we're working in the same laboratory. We're like one big group, okay? So then what do we do once we have the math? Let me explain the math involved. So this is the type of problem that you'll be asked to do. You can, no, don't write this down. I'll go through it, and then you can go back and take a look at it. So a student wishes to find the number of snails in a field that measures 27 meters by 41 meters. Now, I'm okay with the fact that they're counting snails using this quadrat method, even though it's not a plant. But could I count something like mice using the quadrat method? Why not? Jenna, why not? They'll run away on you. Snails, probably moving slow enough that the quadrat method would work. Okay, once you set your quadrat up, you'd be okay. So the field is 27 meters by 41 meters. 5 random 1 meter square quadrats are taken, and the following numbers were determined. There was 3 in one of them, there was 16 in the other, 7, 9, and 14. All right. What's the population, the total population in the field? Okay. So we know that 1, 2, 3, 4, 5 meters squared contain those numbers. So how do we do it? All right. First, average snails per quadrat. How do we get an average? Yep. Correctly. Nice. Nice use of the word numbers. Add all the numbers and divide by the number of numbers. That's exactly correct. So what are the numbers there? Could somebody remember them for me? 3, 16, 7, 9, and 14. Get a calculator out. Help me out here. 3 plus, what was it? 16 plus 7 plus 9 plus, was it 14? 14 equals. Calculator people, what do we got? 6.8. 6.8, no, oh, you've done the average. You jumped ahead too far. What's the total of that? What's the total of that? We got a total? 49. Is it 49? Please, somebody check it. 49? 49. No calculator, Chloe? Nice job. Good mental math. That was good. Good job. Now we're going to get the average. 49 divided by 5, and now 6.8. 60. Yeah, we should be higher than that, shouldn't we? What do we got? 49 divided by 5. 9.8? 9.8? Got other supporters on that? 9.8? That's okay. 9.8 snails per what? And what's the area of the quadrat? Snails per meter squared. So on average, there's 9.8 snails per meter squared. In order to determine the total number, we need the total area. Come on, step 2. We need the total area of the field. So how big was that field? Was it really 27 by 41? You remember that? I'm going to check. I'm going to see if you... Holy crap, good job. That's good memory. 27 by 41. 27 meters by 41 meters. How big is the field? Yep. Well, we don't want it if you don't know if it's right. Marshall, you seem to be our calculator man. Let's get on it. What's the value? 1,107 meters squared. Now, that probably has too many significant digits, right? Remember, we've only got a couple of significant digits. So probably 1,100 is better, but we'll save it for later. We'll save it for later. If there's 9.8 snails per meter squared on average, and the total area is 1,107 meters squared, how am I going to determine the total? We're not dividing. Nope, we're not dividing. You're close, but we're not dividing. Yep. Yeah, we've got to multiply it because there's 9.8 in 1 meter squared, right? Per meter squared. We have 1,100 meters squared. I need 9.8 in each of those. I got to multiply. Okay? Yep. Well, let me just get the step 3 here. Step 3, total population of snails. We got to multiply. I'm going to do it here. This is the total area times the average number equals 1,107 times 9.8 equals, what do you got, Jess? 10,848. Now, look at all those digits we've got there. Do we really know that there's like 0.6? We don't. Notice, how many significant digits in this? 2. How many significant digits in this? 4. I'm likely rounding to 2 digits. It's about 1,100 snails. All right? It's about 11,000 snails. Okay? All right? Okay. That's a lot. Well, we just made those numbers up, but that's a lot of snails. Okay. So, we're going to be looking at dandelions. Now, at this point, I'm just going to stop my delete. No. Oh, I deleted it. Oh, wait a minute.